Take 2, we are on page 19 of our note. We're on simultaneous equation.
Oh yeah. I absolutely love simultaneous equation.
Oh boy.
Sarcasm?
Do you remember that time when we had 10 equations in
Yep.
one question?
Can I have chocolate?
Yep.
Oh, Kyle. Oh, come on, Kyle.
Alright, so did you guys do simultaneous equations last year?
Yes.
Did you ever do it with me?
Um,
Yeah? Yep.
Yeah, we did. Right at the end of year 9. Yeah.
Cool. Alright.
Nope.
Hey, sir, remember that time we had 10 equations in the one question?
Only 10?
Is this
Only, don't say only 10.
right? Oh, this is
Alright, let's have a look.
Guess what, Amanda? I don't have to do peer support. I'm playing soccer.
Alright, so the notes that you guys have been given, it is really important that you are having a look at it and reading through it, because it's not just the example questions I've given you, it is also explaining concepts, it is formulas as well. There will be a point where I'll be writing the questions down. The reason why I am writing questions is because they are there to help me with my answers, okay? So make sure you're reading these notes to help you with your understanding and enhance that. When we solve simultaneous equations, so simultaneous equations are 2 equations with 2 different variables, okay? So we have the variables y and x in both of those equations. If there was only one equation, so we only had the first equation here, Amanda. If there was only one equation, so y equals 7x take away 3, there's actually an infinite number of values you can have for x and y. Okay? It's only when you have 2 equations, you're only going to get one set value. Okay? When we have an example like this. There are 2 methods we can do. Okay? So we have either the elimination method or we have the substitution method. Okay? I'll let you guys read about those methods that I have typed up in the notes there. But either way, the process creates a third new equation with only one variable. So when we have an equation with just a single variable, we can go ahead and solve like we've already done in this topic. So let's label them 1 and 2. So labelling also helps reference how you're going with the question and what you're referring back to as you're working through the question. So this question we are going to do the substitution method. The substitution method is useful when you have an equation like y equals or a variable equals, x equals for example. So both the equations are y equals, okay, so I'm going to use the substitution method and I'm going to substitute into the second equation. So let's do equation 1 and put into equation 2. So in equation 2, where I've got the letter y, I'm going to replace it with what y equals in that first equation. So y, which is 7x take away 3 from the first equation, is equal to negative 5x plus 9, writing the rest of that equation. So now we have a one equation, with one variable. So then we can go ahead and use our skills that we've done at the start of the chapter to solve. So you have a 3-step equation. So you need to remember the 3 steps to solve. Okay, so step number 1, move your variable terms from the right hand side over to the left hand side of the equal sign by performing the opposite operation. So 12x take away 3 is equal to nothing of x plus 9 on the right hand side. So the right hand side of the equal sign has no variable term. Step number 2, we move any constant terms on the left hand side over to the right hand side by performing the opposite operation. So 12x is equal to 9 plus 3, which is 12. And then solve your one-step equation. So x equals 1 is the x value. So we can't stop here because we are asked to solve. It means you need both the x value and you also need the y value. So what you then need to do is pick one of your original equation and substitute x in to get your y. So I'm going to put in 1. So every time there's an x, I'm going to replace it with 1. So y is going to be 7, lots of 1, take away 3, and that will be 4. 7 times 1 is 7, take away 3 is 4. What you should do, I'm not saying you have to, but I'm saying you should, is you should substitute x and y into the second equation. Make sure that holds true. Alright, so test into equation 2. So y is 4. So 4 equals negative 5, lots of my x value, which is 1, plus 9. Alright, make sure both sides the equal sign is correct. We've got a constant number on the left, and then minus 5 times 1, which is minus 5. Minus 5 plus 9 will give me 4. Okay, so it's a good way to check your solution without going through your working again. So therefore, x equals 1 and y equals 4. Right, any questions before we move on to the next one? Alright, let's try the second one. 2x plus y equals 4 and 5x plus 2y is equal to 9. Okay, so there's two methods like I've said already. You need to pick the best method that's going to be most comfortable for you to solve these equations. There's a couple of options you can do. I'm going to do this one with the substitution method, and then the next two I'm going to look at specifically the elimination method. Okay? So, in order to substitute, what I really need is an x equals or a y equals. Okay? So if I look at my first equation, I've got a y, just a y. So if I can rearrange that one, I can then get my equation to have y equals. I could also do that for one of these the variables in equation 2, but that will involve a fraction, okay? I want to not complicate things further than what I need to. Alright, so let's rearrange y to subject. So number 1 you're looking at, so y equals 4, and okay, you're going to move the 2x onto the other side, becomes a negative 2x. Alright, so that's now equation 3. And now we have that one equation, an x equals or y equals. I'm going to substitute it into equation 2. Don't do it to equation 1 because you're going to get an incorrect equation because you're going to eliminate both your variables. Alright, so every time there's a y, I'm going to replace it with the expression of what y equals on the right hand side. So 5x plus 2, need brackets, so 2y, so I'm placing y with that value in brackets like that, and finish off all the variables and constants in that original equation. Right, so you should now be expanding